In this video, we are going to go over amines as weak organic bases. So amines are weak organic bases. Remember, a base is a proton acceptor, and acids are proton donors. So amines react with water like ammonia does by accepting a proton and producing a hydroxide ion in a conjugate acid. So ammonia reacts with water to make an ammonium ion, which is the conjugate acid, and a hydroxide ion. So it takes this hydrogen and it creates this nitrogen-hydrogen bond, which makes it positive. And now this oxygen has only one hydrogen and makes this hydroxide ion. The amine acts very similarly. It will take this hydrogen as well. And now you've created a new nitrogen-hydrogen bond, creating a positive charge on this nitrogen, and you created a hydroxide ion. Since the amine is a weak base, the reaction is reversible and it favors the reactants, the amine, and amines are therefore weak electrolytes as well. Amines react with acids in neutralization reactions that strongly favor the products. So when you put amines in with an acid instead of just water, they strongly favor the products instead of the reactants. The acid donates a proton to the amine and an amine salt is formed. So this is a case of ammonia. So the amines act the same way as ammonia. The nitrogen will grab onto that hydrogen and create this new nitrogen-hydrogen bond that's positive, and you'll create a chloride ion. This together, this ammonium ion and the chloride ion, are called an amine salt. So they're not technically bound together. They're attracted together because they're both ions. And together they're called the amine salt. Many pharmaceutical compounds containing amines are converted into amine salts because this makes them more water soluble, which allows them to dissolve in your bloodstream and be distributed throughout your circulatory system better. So you have ephedrine over here and acetic acid. So this is your acid. Your ephedrine is going to take this hydrogen, and now you have this positive nitrogen and this hydrogen and a negative acetate ion. This right here is an acetate salt. Okay, this is a salt. So it has a ionic, they're ions, and you've created your conjugate acid and your conjugate base. So to practice, we want to write the product of the following neutralization reaction and then label the amine, the acid, and the amine salt. So go ahead and pause the video, and when you're ready, we'll come back and do it together. So the first step in this is the nitrogen wants the hydrogen because we're going to make a nitrogen-hydrogen bond. So I'm going to rewrite it just like how it's shown with the new hydrogen bond. So the new bond, which makes it positive, and our other CH3 bond is still there. Plus, we have our Br minus because we took the hydrogen away, and so now we're just left with our bromide ion. Now we want to label the amine. This is our amine. Our acid is hydrobromic acid. And this together, remember, is the amine salt. Just like salt is Na plus Cl minus, technically together like this in an aqueous solution, not bound together. This is what the amine salt is. It has the positive and the negative ions together, and it's what the salt looks like. So in summary, amines are weak bases analogous to ammonia. In water, amines form hydroxide ions in the conjugate acid of the amine, a positively charged polyatomic cation. Amines react with acids in neutralization reactions to form an amine salt, which is a positively charged conjugate acid of the amine and a negatively charged conjugate base of the acid. The neutral amine is generally not soluble in water, and the positively charged conjugate acid is. And that's why a lot of pharmaceuticals that have amines in it make it into amine salts so that they can be soluble in your body because your body is mostly water.